Greetings. I'm speaking to you from Rescue Shuttle Control. You have triggered an automated rescue protocol on this emergency ship, which will attempt to guide you through the process of activating and flying this rescue craft to safety. Now, this process may take weeks, but our job is to assist you in this effort. I am a pre-recorded AI who will attempt to give you all the information necessary for your success. Our telemetry information indicates that you have activated a rescue craft that has been sitting dormant for several centuries. And this is a problem because this technology will likely be quite unfamiliar to you, unless, of course, you studied ancient computer languages and electronics in school. But don't worry.
Hello everyone, welcome to the live stream. I just wanted to do this 30-day challenge with my subscribers and fans of this Lost in Space, and it's just a great opportunity for us to build together and for you to be in my come build with me space, my live stream. And so I'm gonna do this 30-day challenge. So I'm gonna start the video over because you guys couldn't hear me at first, and so hopefully you heard my speech now, and I will replay the video back for you guys to see the beginning of the challenge again. All right.
Greetings. I'm speaking to you from Rescue Shuttle Control. You have triggered an automated rescue protocol on this emergency ship, which will attempt to guide you through the process of activating and flying this rescue craft to safety. Now, this process may take weeks, but our job is to assist you in this effort. I am a pre-recorded AI who will attempt to give you all the information necessary for your success. Our telemetry information indicates that you have activated a rescue craft that has been sitting dormant for several centuries. And this is a problem because this technology will likely be quite unfamiliar to you, unless, of course, you studied ancient computer languages and electronics in school. But don't worry. I have been programmed to guide you through learning what you need to know. And a step-by-step process over the coming days will allow you to master the knowledge needed to bring this old spaceship to life and to return you safely to your 31st century friends. You must have already figured out that your rescue shuttle is operated using primitive 21st century computers and electronics. So our first step will be to get you started on the basics of those systems. Now, direct neural inputs haven't been invented yet, so all the information going to and from your ship's computer will make use of keyboard input and old-fashioned wired electronic connections. In particular, something called a USB port. We have a USB cable here that should look like the one on your ship. A special purpose computing device called the Hero is vitally important to us for being able to control your ship's systems and functions. The Hero is this device right here, and you should find that among the materials on your rescue shuttle. This hero will communicate, as I said, through the USB cable with your computer, and 21st century computers used different software operating systems, such as Mac OS or Windows, which you may have heard of in your ancient history classes. Now, the information available to us is limited, and we can't tell which of these your ship's computer requires for functioning. So at this point, it'll be up to you to pause and find out what operating system your ship's computer is using, and then follow the instructions that we've provided on your ship that will allow you to install the Arduino software necessary to communicate with your Hero controller. Once that step is successfully completed, then we can continue and resume this first day instruction session and run your Hero through its first test program. But before we do that, go ahead and follow the instructions provided for installing the Arduino software on your computer. And we'll return to this discussion following that. Welcome back.
Yeah, so we're just gonna keep going to the next portion of the video. But yeah, but do pause to do that installation if you haven't already.
Back. At this point, you should have successfully installed the software on your computer necessary to work with the Hero, with our controller. In the days ahead, our plan is to work on building electronic systems alongside the computer code that will function with those electronic systems in order to produce the desired capabilities and results that we will need in order to get your shuttle flying. We'll start out simple with small steps, and then with each succeeding day, we will add new features and new knowledge until at the end you're expert and you will have acquired the ability to fly this shuttle to a safe harbor. Today, we will start with just a very modest test. In fact, we won't actually be building any external circuitry outside the Hero, and we will wait to do that until tomorrow's session. But today, we'll just be testing our ability to command the Hero and have it blink some of its onboard lights, just as a warm-up for doing some of the more important and practical jobs that we have ahead of us. This is a first introduction, and unless you have previous experience, some of the instructions and some of the code that we'll be using will seem obscure at first. And don't worry, in tomorrow's sessions, we will be going back and more slowly reviewing the new concepts, the new language that's needed to follow everything. So don't be worried if some of these things go by fast in today's example. But to get started today, we will have our Hero run a pre-saved example program. This pre-saved example is called Blink, and it should be available to you using your Arduino software. So we will focus our attention now on our code window and work through getting the Blink program accessed and run on our Hero. On the screen, when you begin your Arduino software, you'll probably be presented with a more or less blank sketch window. And in this particular sketch window, there are some somewhat unfamiliar items showing, but they show us something that you'll see in common to all of your code projects going forward as we work through the sessions ahead. We'll talk more in future sessions about the exact syntax of these constructions, but the things that you'll see in common here are a construction called setup and another construction here called loop. And for now, all you need to know is that the instructions inside setup will run a single time when you activate your hero, and the instructions that are placed inside loop will be executed repeatedly over and over again, at least until the hero is shut off. And so these will be the basic structure that we'll be using for constructing more complicated and more sophisticated programs moving forward. So for now, rather than writing our own code right now, we will access through the File menu here. We go to File and Examples. And under Examples, we have a lot of different choices, and we're going to go to Basics. And under Basics, select Blink. So up comes another window containing the Blink program. Now, there's a good deal here that might be confusing, and we're not going to dwell on it right now. A lot of comment lines and background information, but we will go down here to the bottom to the meat of the code and look and see that just as before, in our blank example before, we have a setup routine and we have a loop routine. We'll be learning more about the exact proper construction of these statements in our code, but for now, it should be fairly clear what they're intended to do from the names that they have. There's only one thing happening in setup right now, and it's using a command called pin mode. Now, pin is referring to the outputs that are available on your hero board, and we'll be connecting our electronic circuits to various pins on it. Now, in this particular case, we're not actually using an external pin. We're using one of the built-in functions of the hero. And so pin mode, in this case, is accessing LED built-in, which stands for light emitting diode built-in. So we're going to be blinking one of the lights that's built in to the hero board. And the function that we're assigning to that particular pin is output, which means we're going to tell it what to do. In this case, very simple thing, we're just going to tell it to either turn on or turn off. So that's all that's happening in setup. Down below here, in loop, we have just a few things happening as well. One of the functions that we'll use frequently is called digital write, and it tells a particular pin to do something. So in this case, digital write is telling LED built-in, the one that we assign output function up above here, to go high, or in other words, to turn on. And following that command to turn the LED on, there's a command to do nothing for a specified period of time, that is to delay. In this case, we're asking it to delay for 1,000 milliseconds. And so that is the same as 1 second. So it will wait with the light on for 1 second, then we digital write and set it to low, which will turn the light off. And then wait another 1,000 milliseconds. And then, since this is a looping function, repeat over and over again. So the final result should be that we should see the built-in light on the hero board blink on, off, 1 second at a time, and that should continue indefinitely. So that's our example program. We want to see if it will successfully run. Now, what we should have done before doing all of this is we should have checked to make sure that the hero is correctly connected to the computer and configured correctly. Of course, the first thing that we need to do to activate the hero is to plug in using the USB cable to our computer. And so you can see that upon plugging the hero in to the USB, we have some lights on that indicate that it is connected to power and it's alive. I'm going to come over here to the code window, and I'm going to check and see whether or not things are configured as they should be. So for example, if I look under Tools, I see that I do have this connected to the board Arduino Uno, which is the correct selection among all these possibilities. The Arduino Uno is the one that we should be using for our hero board. So check and make sure that's the case. Another thing that's important is to make sure that we are communicating over the USB serial port. And so you can see that the port here is USB serial 1420, and not, for example, Bluetooth or some other connection that is not appropriate for us. So those all seem to be correct. And so I can go ahead now and try to upload this code to the hero. And if it is successful, it should begin to execute that code, and we should be seeing the onboard LED blinking according to the instructions in the program. So in order to upload it, we click on the upload arrow right here at the top of our window. And after just a second or two, we should see the hero functioning as intended. The onboard LED is now blinking on 1 second, off 1 second, on 1 second, off 1 second. So this is gratifying, and it's telling us that our hero is communicating and functioning properly, and we're ready to perhaps ask it to do more sophisticated things. Now, you can see that we controlled the hero by giving it instructions through the code that we wrote, and in this case, code that someone else wrote, and then uploaded. And among the things that we'll be doing in the future is we'll be modifying code, testing it, finding bugs, finding mistakes, and modifying them. And we'll just give a little example here before we finish, in order to give an idea of what you might do as you're working. I right now have this simple on and off blinking sequence of commands, but I also wrote my own set of commands to replace those that I thought might be worth trying out to see if they would work. So what I'm going to do is I'm going to delete those lines. Let's see if I can select them and delete them, and replace them with a new set of lines. You'll notice that there are more now, and they're slightly different. I'm still turning the light on and off, but in this case what I'm doing is I'm doing it with a different set of timing. So I'm only leaving the light on for 150 milliseconds, and then turning it off, and doing that 3 times in rapid succession. And then, so there's high, high, high 3 times, and then following that with a long delay of 1,000 milliseconds. So this, when I upload it, should change the pattern of flashing from on and off to 3 short flashes, and then a long pause, and then repeat. So when I write new code, it's usually a good idea to test and make sure that there aren't any mistakes in it. So I will click the verify button to make sure that it compiles correctly. It gave me no error messages. It says that it was done compiling. So now I'll go ahead and upload it as I did before. So as I upload the code now, I can see that once it's done, here I have 3 fast blinks and a long wait, 3 fast blinks and a long wait. You may want to try your own modifications of this kind just to make sure that you understand how this all works, although we'll be learning more about how to construct code that doesn't have errors in construction in it as we work through tomorrow's session and the days following. So to this point, this has basically gotten us where we wanted to go on the first day, which was got our hero successfully operating and connected to our ship's computer. Once you have succeeded in running these tests on your hero and your local ship's computer, you'll be ready to start learning more about electronic circuits, about computer code, and all the steps that will be necessary to get you flying and off the planet. We look forward to receiving confirmation of your day one progress and your success in today's task and your readiness to go forward learning more things. So until our next communication session, we look forward to hearing from you. So stay safe and good luck until tomorrow. Signing off.
Well, I hope that wasn't too hard for you to follow and build with me. Until our next stream or live stream to go over the next day 2 task. I hope you enjoyed this setup and introductory to our Come Build With Me. And until the next live, and thank you all for joining, and have a good day.